Alright, I'm going to try to make this video. They are playing the music right now, and we're taking a quiz on this tomorrow, and I can't make the video during lunch or after school, so I got to do it now. Alright, so a lot of you guys asked for this video. I'll try to go as slow as I can, and you'll see why it's a good thing that I flipped the notes and already have my notes written down, so you're not trying to read my writing as I'm going, because my writing's pretty bad. So I'll go as slow as I can. Okay, so what I'm trying to do is I'm trying to figure out what the rule is and what numbers might come next. So I do my first differences. From 2 to 6, that's a difference of 4. From 6 to 12, that's a difference of 6. From 12 to 20, that's a difference of 8. Okay, so I notice it's not constant. It's not a constant rate of change. So I know it's not linear. So then I do my second differences. That goes up by 2, and that one goes up by 2. Okay, because my second differences are the same, that tells me it's a quadratic. And so this is the process that I need to be able to do when I'm trying to get the rule for a quadratic. Okay, whatever I get for my second difference, hold on, let me backtrack a little bit. So because it is a quadratic, I know it's going to be written in the form ax squared plus bx plus c. That's from Algebra 1. But again, because we're doing series, and they always use n, they say find the nth term. So instead of writing ax squared, I'm going to put an squared plus bn plus c. Okay, so now what I'm trying to find, what I need to answer my question, is I got to figure out what a is, what b is, and what c is. So that is my goal. That's what I'm trying to figure out. Okay, so the a is the easiest one to find. Whatever I get for my second difference, which in this case I got 2, I always do this. I put 2a equals whatever I got for my second difference. It's always 2a. Always 2a. Let 2a be equal to whatever I got for my second difference, which in this case was 2. So now it's a little one-step equation. If 2a is equal to 2, then a must be equal to 1. Okay, so I got my first letter. I got a. That's always the easiest one. And like I said in class, a is not always equal to 1, but it's easier if it is 1, so that's the example that I keep giving you guys. Okay, so now I got to figure out how to get b. And I got to figure out how to get c, and then I'll be done. Okay, so what I'm going to do is I'm going to come up right here, and I'm going to rewrite my quadratic. An squared plus bn plus c. Remember, I just figured out what a is. So I'm going to plug in the 1 where I see the a. And so instead of just putting 1 times n squared, I'm just going to put n squared because I don't need to put the 1. So I've got n squared plus bn plus c. Okay, so now this is the part that seemed to confuse. I want some equations to solve so I can figure out what b and c are. So I'm going to plug in for n. Okay, I'm going to come down here at the bottom. I'm going to let n be equal to 1. Now remember, in my series, n is the number, it's the sequence of it's the first term or the second term. N represents the number of the term in my series. So when n equals 1, that means my first term in my series. When n equals 2, that means that's my second number in my pattern. So let me put 1 in for the n. I'm going to let n be equal to 1, and I'm going to substitute it into my quadratic. So instead of putting n squared, since n is equal to 1, I'm going to put 1 squared. Plus b, again, instead of putting the n, I'm going to put 1. 1 plus c. Now remember, the n is the number, it's the number that's in that place. So my first term, when n is equal to 1, that means my first term. When n equals 2, that means my second term. When n equals 3, again, that means my third term, and so on. So when n equals 1, what was my first term? My first term was 2. So when I use n equals 1 and I put it into my quadratic, it should give me 2 because 2 was my first term. So I set this equal to 2. Okay, so now I have 1 squared, which is just 1, plus b times 1, which is just b, plus c equals to 2. Okay, now I'm going to subtract 1 from both sides, and I now get b plus c equals to 1. And I'm going to box that up. Okay, I want one more of these because I can't solve this the way it is. I have two unknowns and I have one equation. You remember, Algebra 1 told us if I have two unknowns, I want two equations to be able to solve that. So I'm going to do the exact same thing I did a while ago. But instead of using n is equal to 1, now I'm going to set, okay, let me set n equals to 2. And I'm going to plug back in the same way I did a while ago. So I'm going to rewrite my equation. I'll put n squared plus bn plus c. But now I'm going to put 2 in for n. So I'm going to have 2 squared plus b times 2 plus c. But if n is equal to 2, what is my second term in my series? If I put 2 in for n into my equation, what is my second term in the series? It's 6. So this has to be equal to 6. So then I get 2 squared, which is 4. 2 times b is just 2b plus c equals 6. Subtract 4 from both sides, and I get 2b plus c is equal to 2. And I can box this one up. Okay, I'm going to slide up because I'm running out of room. So after I do this, what I keep trying to get you guys to do is that second equation that I get, I put that on top. So I put 2b plus c equals 2. And the first equation that I got, I put it on the bottom. B plus c is equal to 1. Now I have a system. And it's going to look very similar to this every time that I do one of these. And all I'm going to do is I'm going to subtract the bottom equation from the top equation. So I'll do 2b minus b, which gives me b. C minus c, that cancels each other out. It goes away. So I just got my equal sign now. And then I have 2 minus 1, which is 1. So I now have my b. I had my a over here. I have my b right here. So now what I need is my c. And the easiest way to get it is to go right back into this equation right there. I already know that b plus c is equal to 1. But now I know that b is equal to 1. So I'm going to use this same equation, but instead of putting b, I now know that b is 1. So I'm going to put the 1 in for the b. So I'll write 1 plus c equals to 1. Because I use this equation substituting 1 for b, because now I know that 1 is b. So subtract 1 from both sides, and I get c is equal to 0. So now I've got all three. There's my a, there's my b, and there's my c. So I'm not done until I rewrite it as a formula, as a rule that looks something like that. So I've got a n squared, but I know that a is 1, so I don't need to write the a. I'll put it right here. N squared plus b times n. But again, b is just 1, so I'm just going to put plus n plus c, but in this case c is 0, so I really don't need to write it. So there's my rule, n squared plus n. And I can check it by going back into my first series. So if I do 1, remember this is n is equal to 1. My first term is when n equals 1. So if I put 1 in for n, 1 squared is 1, and 1 plus 1 is 2. It works. For my second term, n equals 2. N is equal to 2 for my second term, so I put 2 squared. 2 squared is 4, plus 2 is 6. It's working. Let me go to my third term to make sure. When n is equal to 3, I got 3 squared, which is 9. 9 plus 3 is 12. My rule holds. I'm going to make another video. This is the ones that we did in class. It's pretty easy when a is equal to 1. I'm going to make another video to see what happens when a is not equal to 1. It's very similar to this.